Hey everyone, this is Joe from the Document DB team. Thank you for taking time out of your day to spend with us. What we're going to cover in today's webinar is a little bit of background on Document DB, and we're going to spend most of our time talking about what's new in Document DB and some of the things that we've learned and we've added since we launched back in January. So first, I want to just just set the context and give you a little bit of a service overview of why we built Document DB, what's unique about it, and what that enables our customers to be able to do to make their lives easier to build applications. So we built Document DB to be a fast, scalable, fully managed MongoDB compatible database service, and we built it for the cloud, right? We used it. We looked around at how we've seen a number of different database services and AWS services being built, and we really wanted to be able to provide the capabilities that our customers expect from a fully managed database service provided by AWS. So we built this thing for the cloud. It's a little bit different than something that runs on a laptop or on a server. We used the best of breed from technologies to deliver these capabilities. So if we work backwards from our customers and what we really saw in this space, there's kind of two big buckets that provide a lot of challenges. First, and this is kind of broad, for many different databases, is that self-managing, databases is time, cost, it's timely, it's costly, and it's frankly hard. And most folks that are building applications, this really isn't their core competency. They really don't want to be in the business of managing databases. That's what we kind of consider is undifferentiated heavy lifting. And is not something that provides net new benefits or differentiates their product, right? It's just a tax you pay to keep the service or the application up and running. And there's a lot of stuff to do here that detracts away from adding value for your customers, right? So we see that bucket, and that's challenging. We see a lot of folks asking and needing help there. The second one is we just kind of look at traditional database architectures. And they really weren't built for the cloud, right? They were built to run on a laptop or be downloaded as a binary and run on a server. And that was their purpose, and they were built to do, and they do that very well. But we see at the scale and the performance and some of the capabilities that our customers need in the cloud is that those types of architectures can be pretty inflexible. They become hard to scale and recover. Backup becomes pretty challenging, and they have some pretty coupled relationships within the architecture that make these things really challenging. So looking at these two sets of problems, we really looked at Document DB and said, how can we do something differently here? And if you look at what a traditional database architecture is, and this is really true for many databases, whether relational or non-relational, you have a monolithic stack that and I know I'm grossly simplifying this. But does the API parsing and query processing, caching, logging, and storage, and that all resides on one compute instance. And the challenge that we see with that is these architectures scale monolithically, meaning if you want to add a new node to your cluster, you have to copy over the whole stack, including the shared disk. And similarly, they fail monolithically, right? If a node fails and you have to replace it, you have to essentially do the same task. And we'll go through this in a little bit more detail. So we see with customers is that there's a lot of scenarios in which they really want to be able to add additional capacity to their cluster, whether it is a sales promotion or a spike in traffic or seasonality in their workloads. And with traditional architectures, that becomes pretty challenging because to add a fourth instance to a cluster, depending on the level of sophistication of your database team, that can be either a snapshot of an existing node and then bringing that over and rehydrating that fourth node and then doing a kind of a trickle replication from there to catch it up, for the most sophisticated customers. And then for others, it's just providing a new node and just letting it trickle over. And really the challenge there is if you have hundreds of gigs or a terabyte of data, it takes a long time to do that. It can take hours or days or even weeks to add a new node to a cluster. And it takes away resources from the nodes that are in your cluster that are serving customer workloads. So it's a pretty long, lengthy, complicated process that can take a long time. And most folks just aren't. This just isn't their core competency or something they want to have to worry about. Similarly, we see a lot of folks that say, "Hey, I want to run some some pretty big long queries during the business hours of the day, but I don't want to have to pay for that compute capacity when I go home and there's nobody running queries against it. We see this, asymmetric workloads or analytic workloads. We say, hey, I just love to spin up, a large node during the day, let my analysts party on it, and then blow that thing away at the end of the day. But with traditional database architectures, that becomes really challenging. By the time you copy all that data over and you get that thing hydrated and populated, the last thing you want to do is now delete it, right? Because you just spent so much time and effort getting it all established, you don't want to delete it. And for many folks, it becomes cost prohibitive to be able to do these types of scenarios, so they end up having to do this on their primary node or not at all. Right? And failing is the same thing or recovering from failure is the same thing as scaling in many respects. Right? So let's imagine an instance fails. Right? Typically in databases, we'll do a failover, and that typically happens pretty quickly. But then the question becomes, how long does it take for that node to rehydrate, right, and get back to 100% capacity that your cluster was at before that particular node failed? And again, with these traditional database technologies, not only are you down a node, but you still have to burden the other nodes in your cluster to rehydrate to get that third node back online, and that creates a burden on the cluster. And for many folks, they have to over provision to be able to handle that capacity to do this. Right? And then what happens if you have another node fail? You're in trouble. Similarly, with shared disk storages, and I'm sure many folks have been there, is you start off with what you think is a reasonable amount of storage. You say like, hey, 300 gigs, and you have to kind of provision a high water mark, and then so you're paying for unutilized storage space that you're not using. And then somewhere down the line, every month you have a meeting to look at what percentage utilization you have for your cluster, and if you get close to 75%, then you have to go in, do an LVM extend and extend your storage, and set a new high water mark, and you pay for that storage that you're not using, and you continue to do that to the point where you get to the fact that you really can't scale up your storage anymore, and that's when you have to look at different solutions, whether it be data retention or sharding, to be able to scale your workload further. Right, and those are a lot of challenges we see with databases and those architectures. So when we built DocumentDB, we took those in mind, and we really asked ourselves hey, if we were going to build this thing, purpose build this thing for the cloud and use the best practices of the cloud, what would we do? Well, the first thing we would do is separate or decouple storage and compute. And why is that? Well, if you read Werner Vogel's recent blog about building modern applications, you really try to get away from the monolithic architectures for many reasons. But for databases, it comes particularly advantageous as these layers can scale independently of each other. And when we talk about those challenges that we just face, this type of architecture lends itself really well, as we can do a lot of those things in orders of magnitude faster than we could before. The second thing that we did was we split the storage up, and instead of large monolithic, multi-terabyte disks, into a distributed storage volume where we separate the data into 10 gigabyte partitions, and we replicate that data 6 ways across 3 AZs. And why this is useful is that it enables us to be able to survive AZ plus 1 failures. What that means is that if an entire AZ goes down, you still have 4 copies of your data spread across 2 AZs, right? The green squares represent 1 copy of your data, the orange squares represent a second copy of your data. So let's imagine even in a case where 1 AZ goes down, that's a bad day for AWS, your database would still be resilient to that. You would still have a quorum of 4. You'd still be able to write to your database, and you'd have a read quorum as well. Now, let's just say you had an independent failure. One of those green nodes went down in addition to an AZ. On a traditional database architecture, if you lost 2 copies of your data or 3 copies of your data, you'd be in a state of undetermined knowledge of what the durability is for the cluster. In DocumentDB, you'd go into a read-only state, right? You'd have 3 copies of your data, so you'd be able to read, but you don't have quorum, which is 4 out of 6, so you wouldn't be able to write. And in those scenarios, it really matters, at that point, it really matters what your mean time to recovery is. If you have to copy over, 4 terabytes or 100 terabytes or 500 gigs of data, that becomes really slow, right? Because that's a physics problem, how long it takes to copy that data over. If you only have 10 gigabyte partitions like DocumentDB, your mean time to recovery then on that storage node failure is how long it takes to copy 10 gigabytes of data, which happens really, really fast and gets you back into a write quorum and recovered much, much faster than it would to have to recover an entire storage volume. Right? So we see a lot of architectural advantages in this type of approach to building a database. So DocumentDB's architecture is such that you have a distributed storage volume, and then you have compute instances that consume those storage instances that consist of primary or replica instances. The primary instance does reads and writes to the storage volume, and then the replicas act both as read scaling targets or as high availability failover targets. Right? So if we go back to the scenarios that we just discussed, if we want to add additional read capacity to our cluster, in DocumentDB, because of the separation of storage and compute, adding a new replica to the cluster only takes about 8 to 10 minutes, right? It only takes about the amount of time it takes to spin up an EC2 instance for us, lay down our bits for the service, and sync the metadata within the cluster. Because the compute instances are just consumers of the storage volume, we're not doing these expensive, monolithic data syncs across individual nodes. It just becomes another consumer. So regardless of whether you have 10 gigs of data or 4 terabytes, you can add a new instance to your cluster in 8 to 10 minutes, which is orders of magnitude faster than many traditional database architectures. Similarly with failovers, right? When we see failovers, right, let's just imagine a node goes down. What we typically do then is we fail over an instance, whatever the primary was, we fail over to one of the replica instances, and then we promote that instance to the primary. But, when we look at this scenario, there's kind of two numbers that really matter here, right? How quickly can you do the failover? Typically, failovers happen in less than 30 seconds. And then how quickly can we get back to 100% capacity for our cluster? Now, again, because scaling is very similar to, or failures or recovery is very similar to scaling, we can get another node up and running in your cluster in about 8 to 10 minutes and get you back to 100% capacity. Again, orders of magnitude and much, much simpler than having to roll your own solution for this. So for scale-up analytics, very similar. You can say, hey, I want to come to, when I come to work, I want to create a node that's twice or 4 times or 8 times the size of, my traditional nodes. I'm going to be able to run queries on this thing. And then at the end of the day, when I'm done, I'm just going to scale it back down so I don't have to pay for that extra capacity when I'm not using it. And then for DocumentDB, when you create a cluster, and we'll do an example of that when we go into the console, you don't pick amount of storage or IOPS that you need. And the reason for that is that DocumentDB auto grows the storage for you. It starts off at a 10 gigabyte cluster and auto grows that storage up to 64 terabytes without you having to ever go into the console and ever pick a certain volume of storage or a certain number of IOPS to match that storage. It's a pay per use model, and you can consume the storage as your application grows. Same with IOPS, you only pay for what you use. That becomes pretty advantageous as you don't have to think about capacity planning and high watermark and have a bunch of I/O sitting around that you don't use just to make sure you have enough I/O to be able to hit your peak capacity during the day. Right, so that's Amazon DocumentDB. We purpose-built and engineered this database service for the cloud. We have a number of customers that are using the service. They have some valuable to see what they have to say in their experiences moving to DocumentDB, and I'll sprinkle a few of those anecdotes within the presentation. So, we look at this, DocumentDB is fully managed, and what that really means to you is that we handle all of the undifferentiated heavy lifting. We like to say we like to do the ops so you can do the dev. Automatic failure detection and recovery and promotions, patching is automatic. We do a lot of, we handle the durability configurations and all the replication configurations that we do all that heavy lifting, the integration with other AWS services, and of course, the billing model as well. And we see from our customers, like Freshop, is, these are things that just enable them to spend less time on operations, like writing backup scripts, right? Like that's not a differentiated feature from many businesses, and allows that time to be freed up to do to develop new capabilities for their customers. And that's really what fully managed is all about. Scalability, we talked about this through the architectural diagrams, right? We can scale out in minutes, you can scale up in minutes. The storage, and IO auto scale based on your workload. And DocumentDB also supports, we also encourage read scaling on replicas, right? So you can scale out to millions of reads per second on your replicas, and you can still use the client facilities for read preference as DocumentDB supports replica sets. So you can say, hey, for this connection pool, I want to send everything to the primary. In this other connection pool, I want to do a read secondary preferred so that I don't overburden, the primary with these reads, and those can go to my replicas, and I can get a better utilization of my overall cluster resources. And we have a really nice guide in the documentation that goes into that in good detail and provides some code examples for that. This is my favorite feature in DocumentDB because it's one of those things that most folks don't ever think about until it's too late, and then they kind of have a watershed moment of something happened to their database, and then you go back and ask the question, when's the last time we backed it up, or are we backing it up at all? And then it becomes one of those things. If you're not doing it, it's pretty hard to fix that retroactively. So in DocumentDB, we enable backups by default for 1 day. And we provide up to the size of your database for free for backup storage. And why that is that as a fully managed service, we want you to have at minimum 1 day's worth of backup, right? So you can take a point-in-time restore within a 24-hour window. You can extend that up to 35 days if you so choose. But we want to make sure that you have at least one day. You can take as many snapshots as you want. You can archive them for as long as you want. And one of the really nice things about separating storage and compute is that when you take a backup in DocumentDB, it doesn't affect your database performance. Why is that? Well, we're taking the backup at the storage layer. Remember the architectural diagram where we separated the storage and compute? Well, the backup happens at the storage layer. We don't have to go through your instances to be able to take a backup. So we're not using the CPU and the memory that you use and pay for your workload to also do backups, right? That service is, the backup service is decoupled from your compute and does that on its own, so that you don't have to pay for that performance on your overall workload, and that's just something the service takes care of for you. So it's just a tremendous amount of burden that it relieves you from having to think about. You don't have to think about scheduling backups, at 9 o'clock on a Sunday night, so you don't accidentally take down your website or your application because your backup took your app to a screaming halt. Right, and we see customers, like Iron.io is a great example. Is that hey, these are things like backup that we can just offload to AWS, and it just helps them free up time and helps them free up costs as well. So the questions we get quite a bit is around migrations. We have a really nice migration guide here in the documentation. We support 3 different types of migrations to DocumentDB, whether it be offline, using utilities like MongoDB, dump, and restore, and those are really good for POCs. There's online migrations using AWS Database Migration Service, where the database migration service, whether it be the source be any database you want, can do a live migration by being able to pull CDC or change data capture, and then be able to trickle those rights over to DocumentDB. What we see a lot of customers doing is doing a hybrid approach. So they'll do a backup of their current database, restore that to DocumentDB, and then start a change data capture replication with DMS at 1 minute before they took that backup. And that way, a lot of the heavy lifting is done with the dump and restore versus having to do that trickle over of the entire size of the database. All right, so getting started in DocumentDB is pretty easy. I want to actually do a demo on this today using AWS Cloud9. So folks that haven't used Cloud9 before, it's a pretty cool AWS service that allows you to have a web-based IDE in the cloud. But it's also pretty useful for being able to do command or shell interaction within your web browser without having to SSH into an EC2 instance. So let me show you how to do that first. So let's go first, and I'll show you how to create a cluster, and then from that we'll go in and show you how to query it. So we just clicked on, from the services page, I just clicked on Document DB, and here you can see kind of the dashboard that you're typically presented with. I've already created a cluster ahead of time. But if I was going to create a cluster, I'd hit the Create button. I'd give a unique identifier. We provide one for you. I'd select the instance type. Because I'm only going to do dev test, right? We set you up with a highly available cluster, but you can choose one node, and we'll talk about the advantages of Document DB for this particular setup. I would supply my username and password. And down here, we provide an estimated hourly cost just to make it transparent what you're going to get charged for as far as instance costs go. Now I've selected the advanced settings, so just to show a few other options in here that we'll talk about later, right? Encryption at rest is enabled by default. With the parameter group, you'll have TLS enabled by default as well. Again, here's backup, right? It's enabled 1 day. There is no 0 day. You can extend it as you want. You can change that, depending on your needs. And then there's some other advanced features. We'll talk about the profiler a little bit later in the presentation, tagging, deletion protection, and then you can create your cluster. Right? So these are some considerations. We default you to the best practices, but you can go in here and change them if you so wish. So let's go to the cluster that I've already created. And when the cluster is created and ready, you can go in here and we provide a connection string for you. So I'm going to grab that connection string, and then I'm going to go to Cloud9. So let me click on this for a second. And I'm going to open up the IDE I've already created. Now we have a tutorial in our documentation that walks you through step by step on how to do this yourself. Right? All right, so we're in Cloud9, and from this environment, I've already installed the Mongo shell. So I'm going to take that command line and I'm going to copy and paste it in there. And now I'm going to connect to my Document DB cluster. And I'm going to show the databases, and I'm going to look at this taxi data. And I'll see if there's any documents in there. And there seems to be quite a few documents in there. And this is a really great way to be able to query and explore the data and manage, your Document DB cluster using the Mongo shell straight from your web browser. It's a really nice in-browser query experience without having to do any SSH tunneling. Depending on your corporate firewall policy, sometimes that can be pretty challenging. And do this from right within the AWS browser. The one thing that's really nice about Cloud9, if you're not using your IDE environment, after 30 minutes, it stops your instance to prevent any additional charges. So it's helping you save money. All right. So again, there's a tutorial there. One other thing that when I speak with customers, I actually get this question more often than I expect, is that people, they want to be able to use these icons too. They're like, hey, I see these on, this is my architecture and other presentations. I'd love to be able to build, diagrams and be able to use this in my own work. These AWS icons are available to everybody at the URL provided. So I definitely encourage you to go download that if those would be useful to you to use. All right, so we've given a little bit of overview. I want to talk about the things that are new in Document DB. We're going to focus on 6 different areas. Cost optimization, region expansion, security, safe defaults, MongoDB compatibility, and diagnostics. And we'll do a few more demos within these different areas. So cost optimization. Quickly, Document DB is priced on 4 different dimensions, and this is up on our pricing website. And I just want to show that quickly to folks that haven't seen it. Right. So this is the overall web page, the landing page for Document DB, and you can see some more information about features. The pricing website is here. It goes through and tells you very, transparently what the prices are for the different aspects of Document DB, whether it be storage or I/O or instance costs. A few other things worth pointed out is the Getting Started guide. I provide a nice little video, just kind of walk you through the steps on getting through the Getting Started guide. I know some people like to see it visually versus just looking through documentation steps. Something else I spend time on is when we launch things, I add the announcements here, right? So you can see since we've launched, and this is a lot of the stuff that we're going to cover, is here's what's new with Document DB, and here's the stuff we've been working on. When there's new blogs and white papers, I'll add them I'll add them down here as well. And any videos that we create. So this, resources tab becomes a really nice pool of information where you're trying to learn the latest or get up to speed on DocumentDB. Of course, we have the FAQs, to go through some of the commonly asked questions that we see with DocumentDB. And of course, if you want to see what other customers are saying about DocumentDB and their experience, we have a nice customer tab for that as well. All right, so back to the pricing. So within DocumentDB, we have 4 pricing facets, right? We have instance size, and these prices I'm showing you are for US East 1, right? So it's, in this case, 27 cents an hour per instance. There's I/O, and I/O is pay per use. So it's 20 cents per million I/O. Storage is 10 cents per gigabyte per month. One of the common questions we get is, you said, Joe, hey, you replicate data 6 ways across 3 AZs. Do I have to pay for all 6 copies of that data? No, you only pay for 1 copy of that data, right? So if you have, a 60 gigabyte cluster, you only pay for 60 gigabytes of storage for the month, even though we replicate that 60 gigabytes 6 ways across 3 AZs. And then the 4th cost is backup, right? And backup, we give you up to the size of your cluster for free and backup storage a month. So if you have a 100 gigabyte cluster, we give you up to 100 gigabytes of backup storage for a month. And then any additional backup beyond that is 2 cents per gigabyte per month, which is really a cheap backup solution, especially for point-in-time restore. All right, so cost optimizations. There's been some things that have been there since day one, right? We've had pay-as-you-go billing, right? So there's no upfront costs. Everything is transparent. What you're going to get charged is what you see on the pricing page, right? You don't have to talk to anybody to know what those costs are. We don't have any licensing or long-term commitments. And what I really like about that is just as easy as I showed you it is to get started, you can just as easily delete your cluster and walk away, which means that we have to earn your business every day. And we're not going to try to lock you into long-term contracts. Flexibility of the cluster. We're going to talk about this in the next slide, and this one I really like. And this is really unique to the DocumentDB architecture. The other one, this is a really cool feature, and I use it myself as well, is setting up billing alerts through CloudWatch alarms on your cluster. And why this matters is that, we all know, AWS, you get billed on a monthly boundary. So it's not typically, it's not till usually like the 3rd or the 4th day that you get your bill. And if you do something in your AWS account in the first week of the month, and you don't go, like most of us probably just don't go and look at our bill randomly, usually we wait till get to the bill at the end of the month. If you do something that, unintentional, or you scaled something up and you forgot to scale it back down, you usually pay for the cost of that 21 days, 28 days later. What billing alerts allow you to do is say, hey, I know what I think my cluster is going to cost. Let me set an alert at 50% of that and 75% of that, so that if I hit those marks, it's in line with the expected usage that I have. If you set a billing alert on day 4, you hit the 50% of what your expected budget is for that cluster, then you know to go look at something. You don't have to wait, another 30 days before you get your bill to try to go rectify the problem. And we've seen that save our customers a tremendous amount of money, which is great. The third point that we wanted to talk about was flexibility. Now, with the separation of storage and compute, because the instances aren't data bearing, right? It's not a monolithic shared disk architecture. You can actually have if you write 100 gigs of data and you delete all your instances, you can have a storage volume sitting around with no compute instances. Your data is still there. You can't query it because you don't have any compute, but it's still there. That's how decoupled storage and compute are. You can have zero compute instances and still have storage. But we see with dev test scenarios, it becomes much more conscious, like cost conscious, to be able to just have a single instance. If you're just doing dev tests or you're just doing some integration tests, because you still have read write capabilities to your cluster, you still have a durable, highly durable data solution, right? Independent of how many instances you have, we're still going to copy your data 6 ways across 3 AZs, but it's a much more cost-friendly solution. As you build out your application, you can add additional instances, right? So say you went from dev and test, and now you're ready for production or larger scale testing. You can add another replica, again, 8 to 10 minutes, regardless of instance sizes, increase that availability goal profile, and you still have highly durable data. Again, you can continue to add additional instances for even higher availability goal, and additional read scaling as well. So this architecture allows you to, really match your cluster to what you actually want to do with it versus saying like, hey, I need to have 3 nodes for durability because that's just how durability works. And this offers a lot of flexibility for you. All right, so what's new in this space? How can we help you save more money? So we introduced a feature called Start Stop Cluster, and I just want to go show it to you in the console really quick. So if I go back to DocumentDB, and I look at my cluster that's running right now, and I say, hey, it's 3:39. I want to go home. It's the end of the day. I can hit stop. And what this will do is stop my cluster. It'll keep the storage there. And it'll keep the storage there. And then when I come back to work the next morning, I can go back and start it. And that way I don't have to pay for those instance costs when I'm sleeping because I'm not using the cluster. And if you think about it, there's, depending on how you calculate months or hours in a month, there's 700 to 720 to 730 hours in a month. And if you only work, let's say 40 hours a week, 4 weeks out of the month, that's 160 hours of working versus 720 hours in the month. If you stop and start your cluster when you're not working, you can save a tremendous amount of money but by doing that, especially for dev test scenarios. Another thing that we added since we launched was per second billing. So even on your instance hours, not only is it pay as you go billing, but we went down to the second level granularity with your instance costs. So after 10 minutes, right? If you delete your cluster at the 11th minute, we don't round up that entire hour to from a partial hour to a full hour. You only get billed for those 11 minutes within that particular hour, which becomes pretty advantageous, especially if you're starting, stopping, or deleting instances a lot. Those costs add up over time. And the other thing that we did is we started with R4 instances, and along the way we also launched R5 instances in all regions. So if you're using R4 instances today, I highly suggest that you scale or you change your instance types to R5. Same exact cost as R4 instances. In many cases, up to 100 times better performance for the exact same cost, right? That's just free performance that's out there for you to have if you're running on R4 instances right now. Great new hardware, same cost as the R4s. So a lot of these things in combination should help you save quite a bit of money using DocumentDB. Right, and we see our friends at Woot migrated from Mongo 2.2 to DocumentDB, and they actually ended up saving 82% on their costs, going from a self-managed cluster to a fully managed cluster, which is a tremendous amount of value for a team that moves that fast. Security and compliance. All right, so when DocumentDB launched, of course, we had VPC only. We had VPC only clusters, which means you have that nice, strong network partition from the cloud. You don't have public endpoints that people can start probing. Of course, we have encryption by default, both at rest with AWS KMS integration. You can either use the service managed keys, or you can use your own keys to be able to manage encryption, as well as encryption in transit with TLS. And we also had quite a few compliance regimes as well right out of the gate. Right, and when you have customers like Indico, this becomes security becomes pretty binary for a lot of folks, right? Either you have PCI DSS or you don't. And for this particular customer, just having these really made securing their customer data and moving to DocumentDB really easy for them. So what we've added since launch is integration with AWS Secrets Manager. And why that becomes very useful is instead of I hope people don't do this, but instead of checking in your username and password into your code repository, you can integrate with AWS Secrets Manager to get dynamic secrets to be able to use to create connections to Amazon DocumentDB. And on our resources page, there's a really nice blog on how to do that integration within your code. We also added database auditing to be able to do DDL with authorization, authentication, and user management. And those logs get shipped to Amazon CloudWatch Logs, where you can use CloudWatch Insights to query and parse through those logs. And we also added SOC 1 and 3 compliance as well. All right, safe defaults. Now, this is something that we feel pretty strongly about as a fully managed service. Our thoughts on this as a fully managed service is we want to set you up with what we believe are the safe defaults. And if you want to opt out of those safe defaults, that's totally within your power and totally within your control. But we just want to make sure we set you up with the safe defaults to start with, and then have it be a conscious decision. So if you say, hey, I don't want to encrypt my data at rest, well, that's something you have to explicitly turn off. And we're okay if that's something that you choose to do, versus kind of the reflexive of that is saying like, hey, I've been running in production for 4 months and I didn't realize that my data wasn't encrypted. We'd rather much you have the conscious decision that you turned it off, or it's going to be there by default for you. So out of the gates, DocumentDB is VPC only. Encryption at rest and in transit are on by default. Of course, you get all those compliance regimes, whether you use them or not. They're there. We abide by them. So you get those best practices. We're durable by default. You don't have to configure anything for DocumentDB for your data to be durable. Again, we enable backup by default, authentication by default, and it's highly available by default. When we create a cluster in the console, we set you up with a 3-node cluster. You can change that, but that's something that you have to opt into changing. One of the new features that we've added recently was deletion protection. And I want to show you this in the console really quick. So to be able to delete a cluster, I have to delete the last instance in the cluster. And if I go up here and I say delete, this is enabled on my cluster. So it says, hey, to delete this last instance, you have to modify the cluster and disable deletion protection. Why would we do that? You'd be surprised how easy accidents can happen where somebody runs a script and they accidentally delete their production cluster. And that becomes a big problem because sometimes they also delete their snapshots as well. And honest mistakes happen. So this is part of, we believe strongly in a fully managed service is to provide these types of controls that help you protect yourself from accidents. So we can go in and we can go back to clusters and, maybe I don't want this one anymore. And I can modify it, right? And I can say, hey, let's disable deletion protection. And I can say, hey, apply immediately. And then I can go in and delete my cluster. But it forces me to take that extra step to really verify that I really want to delete it. And deletion protection works both for the console and for the CLI and CloudFormation as well. So if deletion protection is enabled, you can't delete your cluster unless you explicitly turn that off. All right, regions. So we launched in 4 regions. We've been adding regions at a pretty good clip with Frankfurt and Tokyo and Seoul and Sydney and London. Definitely more on the way, I can tell you that. And in the fullness of time, we'll be on all AWS regions. So we'll continue to work hard to close that gap. MongoDB compatibility. So, available since day one, DocumentDB is a MongoDB compatible database service. It's compatible with the 3.6 wire protocol. That enables you to do is use the same tools, drivers, codes, application that you're running today and be able to point it at DocumentDB. And we talked about a little bit earlier, we also do replica SEP emulation that allows you to do those niceties in the MongoDB drivers to be able to route your request to the node based on kind of the read preference or the consistency level that you need for the reads in your workload. So DocumentDB is not 100% MongoDB compatible, and just want to be straight and make sure everybody's fully aware of that. We document very clearly what APIs we do and do not support. And when building DocumentDB, we really worked backwards from the customers that we were working with in preview, and we started off with those APIs that were really core to getting those customers into production on DocumentDB. And we've used the time since we've launched to really listen to our customers and deliver the APIs and the functionality that our customers really want, right? In fullness of time, we're going to close the gap, but we're going to focus on building the features and the APIs that really matter to our customers. If there's a bunch of aggregation operators out there that nobody ever uses or ever asks for, we're going to spend our time innovating on other areas to help our customers, maybe scale better, have better performance, achieve more cost savings, right? We're not in it just to build it for if we're not working backwards for a customer. So we make that really clear in our documentation. We put that out there to make that transparent for you. We also document the functional differences that we have, just to make that aware, and so you go into it with eyes wide open. So, since we've launched, we've gotten a lot of feedback of additional capabilities that customers want us to add, and we're going to continue to add to this. We got some more coming shortly that are going to be coming down the pipeline, and we'll continue to work backwards and build the stuff that our customers want. So here's quite a few of the operators that we've had delivered since launch. Again, you can find each of these in the resources, and you can expect more in a pretty continual fashion until we don't hear, until people quit telling us to build new stuff. All right, diagnostics. So again, from day one, we've had operational metrics like buffer cache hit ratio and CPU utilization and replication lag, freeable memory, all those operations within CloudWatch logs, and you can use those to monitor and alert on your cluster. API service API usage tracking through AWS CloudTrail. And what that means is a lot of the API commands all of the API commands that you make through the AWS CLI or through the console get logged to AWS CloudTrail. So if somebody deletes a cluster accidentally, at least you can go into CloudTrail and understand who performed that action. And of course, even within the database service, within DocumentDB, we support a lot of the MongoDB diagnostics like KillOp, CurrentOp, Explain, and more. What we've added since launch, and this was a big customer ask, and I'm pretty excited, is really helps our customers better utilize their resources and better tune their applications, was the Slow Query Logger. What the Slow Query Logger allows you to do is you can enable it on your cluster, and when you do, you can specify a threshold for the query the query duration. Say by default it's 100 milliseconds, unless any query longer than 100 milliseconds will be logged to CloudWatch Insights. And then you can use CloudWatch Insights to be able to understand what those queries are, so you can go look at them and see if there's some tuning that can be done or indexes that can be added to increase your overall database performance. So let me show you how that works. So for this particular cluster, I already have slow query logging enabled, right? So I'm going to go to Amazon CloudWatch, and I'm going to go over to logs, and I'm going to see the namespace for my cluster. And I've already, this is on that taxi ride data that I showed you earlier. I've already run a slow query. Basically, I have a collection with no indexes on it, and I basically did a count with a predicate filter. And because it's a collection scan, right, you're just going to do a full collection scan of that data, and that's not super fast. But I logged that query, right? And you can see that, hey, that actually took quite a long time, and it logged the query in a CloudWatch log. So now I can go in, I can see what the explain plan was for this, right? And I can also see what my query was, right? I said, hey, I want to do a query where the fare.total amount equals $15.30. And I can go in here and I can say, well, I just did a collection scan. Looks like I don't have an index. It would probably be super useful for the performance of this query if I went in and added an index on this particular path. And that way I could do an index lookup versus a collection scan. So it's a super useful feature to be able to understand what the performant or non-performant queries are in your cluster to help you continually improve performance and utilization. Our friends at Datadog added integration for DocumentDB, and we'll continue to partner with folks like Datadog, who provide really great capabilities that help extend DocumentDB. And we'll continue to work backwards, again in this space as well. We had a lot of folks request top and index stats so they could look at what their index profiles were across their collections. Hint to be able to force the query processor to use a particular index if they wanted to, and we'll continue to invest in this space. So what's next? I think folks, from this webinar, I think you've been picking up what I've been laying down is we're going to continue to work backwards from our customers, and this is really what we really care about. And I think what we'll never hear from our customers is they want us to make the service slower. They wanted to make it less managed. They wanted to make it more expensive. So of course, we're going to continue to make it more performant, less costly for you, and increase the fully managed capabilities to remove more and more time that you have to spend thinking about your database, so it can free you up to do other things. And we're going to continue to increase our compatibility with MongoDB, working backwards from the feedback that we get. We'll continue to always invest in those areas. All right, so where can I find additional resources? We did a little quick tutorial through kind of the DocumentDB landing page, and we showed you pricing and FAQ and the resources. Here's a few other pointers. The documentation is also a really good resource there. If something's not clear or something's not correct, please definitely use the feedback in the bottom of the pages to be able to send that to us. I get an email when that happens, and that allows us to fix those issues or make it clearer for you, so that not only you but others can benefit down the path as well. All right, so 3 things to remember. We built DocumentDB to be native for the cloud. It's a native cloud architecture that separates storage and compute, that provides a lot of capabilities that allow our customers to build MongoDB applications at scale. It's fully managed, right? We do a lot of things for you so that you don't have to, and we'll continue to invest in that space to make it even easier for you to use. And getting started is easy, as we saw a little bit earlier. It's right in the AWS console, a few clicks of the mouse, and you can use services like AWS Cloud9 to be able to have a really nice in-browser query experience to get started without having to go outside of even the AWS Management Console. With that said, I appreciate your time today. Thank you very much, and I'd be more than happy to take the questions that you have now.